So this is a pretty cool problem. We got three particles, A, B, and C. The first one is going to be positive or negative 11e. We don't really know. The third one is 11e for sure. And then this one in the middle is actually Q. We don't know that one either. But we're given this graph here, and we're shown that when x is equal to 0.8, then the net force on this particle in the middle, B, is actually 0. But we're also given that when this particle becomes so far away on this side that it's gone, this is gone, then we actually get a little bit of a positive net force. And so if we took away this particle and we just focused on that last bit, then we would know that these two particles are actually pushing on each other kind of like this. This one's pushing this way a little bit, this one has to be pushing this way a little bit in order to get that positive net force, okay? That's the only way. And so once we push this particle back closer to it, we realize it has to be pushing this direction to equal that out, and then this must be pointing that direction, which means that everything is actually going to be like positive and repelling itself, because these two have to be positive to repel each other. That means Q has to be positive, and these two have to be repelling each other. So, well, because that's positive, then that must be positive as well. So, you know, this is positive. So, that's pretty cool. We also figured out that, if these two were really close together at the same point here, 0.8, then this would be equal to each other, which means that this side has to be equal to 0.8 meters. That's kind of another given, because once you put that at 0.8, it's equal, you know, that's going to be 0.8, because these are also equal charges as well, of course. So now we've discovered the length of that second part on the left, and with that, we can calculate that force A on B is actually going to be this. Force A on B, these two by themselves, without C even, is going to be K times 11E times Q divided by the 0.8 squared. And then, because C is gone, taking that out of the equation, we can just actually equal this to the positive net force that we have over here. So 1.428 e to the negative 25. And now we can just solve this for Q. 1.428 times 10 to the negative 25. And we're going to multiply that by 0.8 squared. And divide out K, which is 9e to the 9. And divide out 11. And now we have to divide out the E again to make sure that that is gone, e to the negative 19. So we're left with the Q is going to be equal to 5.7625 e to the negative 18 coulombs. Okay, this is the charge. Now, in order to represent charge in terms of E, we have to divide that again by E, and we'll get that Q equals 36E. And that is the answer, finally.